Good day. My name is Piar and Dayto, and I explain how to solve a linear programming model. And this is the problem that we create. A company manufactures and sells two models of lamp, which is L1 and L2. To manufacture each lamp, the manual work involved in model L1 is 20 minutes and for L2 is 30 minutes. The mechanical or machine work involved for L1 is 20 minutes and for L2 is 10 minutes. The manual work available per month is 100 hours, and the machine is limited to only 80 hours per month. Knowing the profit per unit is 15 and 10 for L1 and L2, respectively. Determine the quantities of each lamp that should be manufactured to obtain the maximum benefit. Step 1. We identify the variables, which is x is equal number of lamps L1, y is equal to number of lamps L2. Step 2. Write the objective function. F open parenthesis x y close parenthesis is equal to 15x plus 10y. Step 3. Write the constraints as a system of inequalities. We convert the time from minutes to hours. 20 minutes is equivalent of 1 over 3 hour. 30 minutes is equivalent to half hour. 10 minutes is equivalent to 1/6 hour. And the equation is 1 over 3x plus 1 over 6y is less than 2 or equal to 80. 1 over 3x plus 1 over 2x is less than and equal to 100. As the number of lamps are natural numbers, there are two more constraints, which is x is greater than or equal to 0, y is greater than or equal to 0. Step number 4. We choose the method to solve the problem. Here, we will solve this problem graphically.
Hi, this is Justin Klein of Javier, and I am now explaining our linear programming model. So first we identify the decision variables, which is x will be the number of lumps or lump number 1, and y will be number of lumps or lump number 2. Next we input the objective function or the function, which is fxy is equals to 15x plus 10y. Then we convert our constraints into minutes to hours, which is 20 minutes into 1/3, 30 minutes into 1/2, 10 minutes into 1/6. So 1 over 3x plus 1 over 6y less than 80, and 1 over 3x plus 1 over 2x will be less than 100. So first we use as our x and y is the value 0. So we substitute the 0 to the x and y. So first one third. So first, uh, 1/3 multiplied to 0 plus 1/2 multiplied to 0 less than 100, and 1/3 multiplied to 0 plus 1/6 multiplied to 0 is less than 80. So, as we graphed it in the Desmos, we got the intersection point is 210 and 60. So, we find the optimum point. That being said, let the 100 be the y and x is 0. So, 1 over 3 x plus, no, 1 over 3 multiplied to 0 plus 1/2 multiplied to 100. So, we got, no, our vertex is 0 to 100. Then, on the other hand, 1/3 multiplied to 0 and 1/6 multiplied to 80, and we got 240 and 0. So, To get the optimum point, or for to solve it, is use the no substitute the value of the vertices or vertex, which is f 0 to 100, no 0 and 100 is equals to 15 multiplied to 0 plus we will use our objective function, and we gonna substitute the vertices that we got. So f 0 and 100 is equals to 15 multiplied to 0 plus 10 multiplied to 200 is equals to 2000. Then f 240 and 0 is equals to 15 multiplied to 240 plus 10 multiplied to 0, we got 3600. So to get the maximum models, we use the point where they intersected, which is 210 and 60. So f210 and 60 is equals to 15 multiplied to 210 plus 10 multiplied to 60, which is 3750. For our optimum solution, we got 210 units of lump 1, 210 units of model lump 1, and 60 units of lump model lump 1. No, lump 2. To obtain, no, to have the benefit of, no, to have the profit of $3,750.
Calculate the value of objective functions of each of the vertices to determine which of them has the maximum or minimum values. In the objective function, place each of the vertices that were determined in the previous step. The optimum solution is to manufacture 210 units of model L1 and 60 units of model L2 to obtain a benefit of 3,750 pesos.